Hello, this is Mr. Collier, and today we're doing implicit differentiation. It's a very important topic. This one always comes up on IB exams. First, unrelated trig starter. Now we're going to be solving for tan 2 theta, so recall we have to change the domain to be 2 theta as well. So I'll multiply everything by 2, and this becomes 2 theta, and this is pi and negative pi. Okay, so to solve, we do positive negative square root, so tan 2 theta equals positive negative 1. And then we'll look at where is tan equal to 1. That's in the this triangle here with the angle pi over 4. And we're looking at positive negative 1, so it's actually going to be 4 answers. One here, 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 and here. Alright, so 2 theta is going to be equal to pi over 4, and then this angle here is 3 pi over 4. This one is negative pi over 4, and then we have negative 3 pi over 4, and then I'll just divide by 2. So we have pi over 8, 3 pi over 8, negative pi over 8, and negative 3 pi over 8 are our 4 answers. Okay, so next we're going to look at some actual implicit differentiation. So this kind of equation where you have it solved for y is called an explicit equation, and this one is called implicit where it is not solved for y. Okay, and often these things, like this is a function. This one is a circle, so you can't really write it as in terms of y unless you use a positive negative sign. Okay, so a lot of our graphs today are going to look sort of like this. When differentiating implicitly, we need to use the chain rule. So basically what you do is you differentiate every single term. Okay, but we're differentiating with respect to x. So when I differentiate this, you get 2y, of course. But we're differentiating with respect to x. Y is a function of x, so you're going to multiply by dy dx, which is basically the chain rule. Next, the derivative of sine is cosine. Well, we've got a y here, so we've got to multiply by dy dx by chain rule. And now we have actually a product of functions. One function is 2x, the other one is y. So we've got to use the product rule. Derivative of 2x is just 2, so we have 2y plus 2x times the derivative of y, which is again dy dx. And then we got a derivative of x squared is 2x. And on the other side, derivative of constant is just 0, right? Okay, so in some cases we just want to leave our answer like this. In some cases you actually want to solve for dy dx. And we do that by factoring out dy dx in all the terms in which it occurs. Okay, so we have 3 terms with dy dx. So we're going to factor out dy dx. And we have 2y plus cosine y plus 2x. Bring the other terms to the other side, that equals negative 2x minus 2y. And then we can just divide, so we have dy dx equals negative 2x minus 2y over 2y plus cosine y plus 2x. Okay, next let's look at this one. So let's find the derivative. Derivative is 2x plus 2y, but then for this one we have an extra dy dx. Sometimes we write that as just y prime, just a different notation. It's a bit easier to use, right? Okay, so then we get this, and so y prime equals negative 2x over negative 2y, which equals x over y. Actually, that's should be positive, so it's negative x over y. So recall the graph of this is actually a circle with radius 5, and point 0.34 is somewhere like here. Alright, so find the equation of the tangent to the circle at that point. We can do that with using dy dx, right? So the slope equals negative x over y at any point along the circle. And at this point, we just plug in the 3 and the 4, and we have the slope. And this is where the now the point slope form is going to be very, very useful when we do these kind of questions, because to write the equation of the line, we could just use point slope form. So y minus 4 equals the slope times x minus 3. And no need to simplify it. Sometimes that will be really complicated actually. In Desmos, there's the circle and there is the tangent. You see it is tangent at the point 3, 4. Okay, so next question. So differentiate that is going to be very similar to what we already did, so we're just going to skip that one. Let's do this one here. So when we find the derivative of sine is cosine. The x plus y is the same, but we got to multiply by the derivative of x plus y. That is 1 plus dy dx. On the other side, we got a product of functions, so we have to use product rule. So derivative of y squared is 2y times dy dx cosine x plus y squared times the derivative of cosine, which is negative sine x. Okay, so if we want to solve for dy dx, we'll expand this, and we have cosine x plus y plus I'm going to start using y prime to make it a bit easier here. Cosine x plus y equals, let's say y prime times 2y cosine x minus y squared sine x. And now we got y prime on both sides, so we need to get it all on one side. So we're going to have y prime, and we're going to have cosine x plus y. And if I bring this to the other side, it's going to be a minus 2y cosine x equals, this is going to be negative y squared sine x minus this term that doesn't have the y prime. Okay, so y prime, or dy dx, is going to be equal to this divided by this, right? So it's negative y squared sine x minus cosine x plus y over cosine x plus y minus 2y cosine x. Alright, so next, this is the symbol for the second derivative. So we find the derivative twice, or you can write y double prime. Alright, so we're going to find the derivative twice. Derivative is 2x plus 3y squared times y prime equals 0. That's the first derivative, right? And now we can do it one more time. So the derivative of 2x is just 2. And then derivative of this is going to be, now we're going to use product rule because we have the product of two things. So that's going to be 6y to the power of 1, right, when I find the derivative. But as a function of x, so I got to multiply by y prime. So that's the derivative of 3y squared. And we got this other y prime right here, so there's two of them. Plus, because I'm doing product rule, 3y squared times the derivative of that, which is the second derivative. And we still have 0 on the other side, right? So what we need to do now next is we can actually substitute a value for y prime. If we solve this equation, we have y prime equals negative 2x over 3y squared, right? So we can plug that into this one right here. Alright, so we're going to have 2 plus 6y, now this is y prime times y prime, so it's y prime squared plus 3y squared, y double prime equals 0. And I'm going to be solving for y double prime, so let's get that by itself. We're going to have a negative 2. This is going to be positive, but we're going to bring it to the other side, so it's going to be negative. 6 times this is going to give me 2 times 4 is going to be 8. The y's are going to cancel. You're going to have 8x squared over y. And now y prime equals I'm going to multiply both sides by 1 over 3y squared. So it's going to be negative 2 over 3y squared minus 8x squared over 3y cubed is the final answer. Okay, next we're going to find the derivative of ln x. We're actually basically going to prove the formula in the formula booklet. The derivative of ln x is 1 over x, right? So you can do that with e to the x. You can just say e to the y equals e to the ln x, which is e to the y equals x, and then we can find the derivative of both sides, right? So the derivative of the left is ey times y prime, and the derivative of x is 1. So we have y prime equals 1 divided by e to the y is e to the negative y. And what we can do now is we can substitute back in ln x for y. So e to the negative ln x, which equals e to the ln x to the power negative 1, which equals x to the power negative 1, which equals 1 over x. Okay, so that's why the derivative of ln x is 1 over x. We can do something similarly with the next one. We have ln y equals ln 5x, so ln y equals x ln 5. Then we can find the derivative. So the derivative of ln y is 1 over y times y prime, and the derivative of this is just ln 5. So y prime equals y ln 5, and then we can substitute back in y, which is 5 to the x. So we have 5 to the x times ln 5 is the derivative of 5 to the x. Okay, next example. Okay, so let's do implicit differentiation. The derivative of that is always exactly the same, then chain rule. And this is going to be product rule because it's x times y. So we're going to have y plus x times y prime. And now this one here is easy to use a log rule first. We can write this as 2 ln y. Okay, so that means the derivative of that is 2 over y times y prime by chain rule. And this e to the y is going to be e to the y times y prime. And on the right hand side, actually, this is all constants, so it's just 0. Okay, so let's expand this bracket here. We have y e to the xy plus e to the xy times xy prime, and this is pretty much going to be the same. Alright, now let's get our y primes together and factorize. So y prime times, this is x e to the xy, so that term. And then this one here is 2 over y, and then we have another y prime. Is this, so this should be multiplied here. Oops, I messed that up. This should be, yeah, plus, that's right, e to the y. And get the other stuff to the other side. What else is there? Just this one here, is it? So that's negative y e to the xy. So we have dy dx equals negative y e to the xy over x e to the xy plus 2 over y plus e to the y. And then we want to get rid of the fraction within a fraction. We can multiply numerator and denominator by y. So we'll have negative y squared e to the xy over xy e to the xy plus 2 plus y e to the y. Okay, in our next example, we're going to find the equation of the normal to the curve. Alright, so let's, well, actually first, and we're obviously going to have to find the derivative, but we will need the y value at this point. Okay, so we will need that in a second, so let's go ahead and do that first. To get the y value at this point when x equals root 3, we're just going to plug in root 3 for the x value, right? So we're going to have root 3 squared minus root 3 times root 3 times y plus 2y squared equals 5. So that's 3 minus 3y plus 2y squared equals 5. Now this is a quadratic, so we have 2y squared minus 3y minus 2 equals 0. And that will factorize to 2y plus 1 times y minus 2 equals 0. So y equals negative half and y equals 2. So we actually have 2 points where the 2 points where x equals root 3. We have the points root 3 negative half and root 3 2. Okay, so let's handle both those. Actually, we're going to need the derivative next, and then we can find out the slope of the tangent line at those points. Okay, so we'll do implicit differentiation. So here's the derivative. 2x, and this is a product, so we're going to do product rule. So this is minus. Now don't forget this minus applies to the whole thing here. So when we do the product rule, minus is going to apply to both terms. So derivative of x is just 1, so we're going to have root 3y. And then derivative of y is going to be y prime. And then we'll go into this one. This is going to be 4y times y prime. And 5 is just a constant. Okay, let's simplify and solve for y prime. So this is 2x minus y root 3 minus x root 3y prime plus 4y y prime. And let's get the y primes together. So we have y prime 4y minus x root 3 equals, and let's bring this to the other side, we have y root 3 minus 2x. So y prime equals y root 3 minus 2x over 4y minus x root 3. Okay, so then we need to use, figure out the slope at both these points. So let's do that one first, root 3 comma negative half. So the slope of the tangent at that point, well actually let's go straight to the normal. So if we do the normal, actually I'm going to do the other point first, because I know it's a little bit easier. Let's do this point first. So the slope of the tangent at that point is, well, we have to plug in both the x and the y values. So y equals 2, and then root 3 minus 2 root 3 over 4y, so 4 times root 3, x root 3, so that's root 3 root 3. That should be a minus in between. So notice the numerator is 0, so the slope of the tangent equals 0. That means, so the tangent line is going to be horizontal. That means the normal line, which is always perpendicular, is going to be vertical. So the slope of the normal is going to be undefined. Okay, that means we have a vertical line. So the equation is just going to be x equals root 3 because it goes through root 3. So that's the equation of the normal at this point right here. Now for the other one, the equation of the normal is, now recall the slope is going to be perpendicular to the tangent, so it's going to be negative reciprocal of this, of the derivative, right? So negative reciprocal is going to be negative 4y minus x root 3 over y root 3 minus 2x. And we're going to plug in those values. So it's negative 4 times negative half minus the x is root 3, so we have root 3. And here we're going to have half, or negative half, times root 3 minus 2 root 3. Okay, to get rid of this half, I'm going to multiply numerator and denominator by 2. Then we're going to have this 2 and this one cancels. We're going to have negative 4 minus 2 times, that's just 3. And in the denominator, we're going to have negative root 3 minus 4 root 3. Okay, Now all of these terms here are negative, so actually I can change them all to positive. It's going to be 4 plus 6 is 10, and it's going to be 1 plus 4 is 5. So the slope is actually negative 2 over root 3. Okay, so to write the equation of this normal line, we just need to do point slope form. So y minus, y minus, or what's going to be y plus half equals the slope times x minus root 3 is the equation of that normal. Okay, and I've prepared these graphs on Desmos too, so you can take a look. Here's what the graph looks like. It's a very interesting looking ellipse. And here is y equals root 3. You see it is normal at this point right here, right? And here is the tangent at that other point, which is at 3 negative, what was that point again? That's this one right here. So the point is root 3 negative 2. So this is root 3 negative 2 down here. Yeah, that's root 3 negative half. Okay, so that's the tangent, and the normal is right there. It's perpendicular to the tangent.